Hello, everybody. This is Mr. Bowman. So today is just a quick look at some of our basic transformations. So we're going to take a shape, whether it's a point, a line, a quadrilateral, a triangle, it doesn't really matter. And we're going to do a couple basic transformations to it, which means we're going to move it around our graph in different ways. So what we're going to do is we're going to spend some more time on each of these individually later. This is just kind of an overview of how they work to try and visually see what's going on so you can kind of track along in your head as we do these. So here I have a quadrilateral ABCD. And the first one we're going to look at is known as a translation. Okay. So a translation, already moving it. So a translation is sometimes known as a slide because what it is we're going to actually take this shape and move it around our graph, right? So you can translate in really, since we have two axes here, this is a two-dimensional graph, so we can translate it in really four directions. So we have up and down, or we have left and right, or it could be a combination of that. So let's say I start with ABCD here, and I want to shift it down, let's say down 3. I'm going to take that and then go down 1, 2, 3. And this would be where my new graph is located. Okay, so our original one, let's go ahead and put it on our permanent graph here, is there. A, B, C, D. And then if I shift it down 3, I'm really taking each of those points and going down 3. So the whole thing is just kind of sliding down 3, hence sometimes known as a slide. So that would be here. Okay. And to make sure we know what we're talking about, we're going to use these same letters. But to differentiate, we're going to put a prime. So it's going to be A prime, B prime, C prime, and D prime. So that's the new A point, the new B point, the new C point, the new D point, to give you all of those. And that's just a translation. So you could do that in a couple orders. You could say go down 3, then left 10, or something like that. And that would give you a single one moving from here to here. So it's almost like, looks like it's sliding diagonally because we're going to put those together. Okay. So the next one we're going to look at is known as a reflection. Okay. Or colloquially known as a flip. And that's when I'm going to take my graph itself and actually flip it over so it's reversed. Okay, so we could flip it this way, or we could flip it down, but it's going to be known as a flip. Okay, so in that case, we're going to still start with the same graph here. A, B, C, D. And then say if we flip over the y-axis, it's going to be reversed and over here, which is a little bit harder to see, but hopefully you can kind of see through the paper there. I should have used a thinner paper, that it ends up being reversed like that. So it'll end up being with, instead of C being to the left of D, our new C will actually be to the right of D, because when we flip it over, okay, so it'll end up looking like this. A prime, nope, ooh, my apologies. A prime here, B prime. Sorry about that, I had an announcement. So here will be C prime and D prime, and that would be our reflection. So same shape, but turned over, or if you're reflecting over the x-axis, it would flip down. Right, the last main one we're going to look at is known as a rotation. So these can be rotations around the origin. So we're going to rotate here like this, and actually kind of spin our shape to one of the other quadrants. Okay, so this is a rotation, known as sometimes as a turn. Okay, or a spin. I've heard that as well, but I've heard turn more often. So this one is one of the trickier ones, and we're going to get into it more But I want to make sure we point out a couple of things. So if you don't move at all, that's a 0-degree rotation. Going one quadrant around, and we're moving counterclockwise whenever we're doing this. So one quadrant would be 90 degrees, two quadrants would be 180, and three quadrants would be 270, and then 360 would be all the way around and be the same as a 0-degree rotation. So, and that's not saying that everything in this quadrant is 90 degrees. That's not what I'm saying. But since I'm starting here, I'm labeling it relative to this picture. So if my original one was here, this would be 90 degrees because it's one quadrant counterclockwise from where we started. So, but I'm starting in this first quadrant, so that's why I label it that way. So if I want to do a, say, 270-degree rotation, I'm going to spin this all the way around, and it will end up looking like this instead of my original picture. So this was my original. And then this would be my new one. Okay. So that would be here. And these are congruent. I know it doesn't look particularly like they're congruent because I made a mistake when I printed out the graph paper, so they're not actually square. They're a 4:3 aspect ratio. So they're slightly off there. So I apologize that it doesn't look perfect, but they should be congruent after all of these because there's something known as a rigid transformation. So they should end up congruent. And last thing is just a little bit of vocab because you're hearing me refer to the old shape, the new shape, and that gets tiring. So our old shape actually has a real name of the pre-image, and the new shape is known as the image. So you're going to start hearing those terminologies. So all of these original ABCDs are your pre-image, and then the new ones, where it's A prime, B prime, C prime, D prime, are going to be known as your image.